Welcome back, everyone. This is Dr. Shah Fahad Khan on your screen. And today we are going to do atomic structure lesson number 2. In this lesson, we are going to see the behavior of beams of protons, neutrons, and electrons moving at the same velocity in an electric field and determine the number of protons, neutrons, and electrons present in both atoms as well as ions, given the atomic or proton number, mass or nucleon number, and charge. And at the end, we are going to also do a few exam type questions based on this lesson to apply your knowledge. Let's get started now. Okay, guys, so you can see this electron beam right over here. Let me just shrink this a bit. Yes, this is the electron beam. In this electron beam, now protons, neutrons, and electrons, a mixture of all three, is incident towards this electric field. The upper pole is negatively charged, the lower plate is positively charged. Now, as these three beams try to enter the field, the neutrons, which are neutral, will be unaffected by the field because they are neutral, they don't have any charge, so no electrical force would act on them and neutrons will pass straight. But protons being positively charged, and you guys know that unlike charges always attract one another, these protons being positively charged would be attracted towards the negative plate. And so the beam is going to move upwards. What about the electrons? Electrons being negatively charged would be attracted towards the opposite plate, meaning positive plate. So they'll be attracted towards the positive plate and the beam will be deflected towards the positive plate. But if you could compare the three pathways of the three particles, especially the protons against electrons, you can see that the angle of deflection or the curvature of the pathway of electrons is much more than that of the protons, which is because of the fact that electrons have a lighter mass as compared to protons. Or even though the charges are the same, but the mass of electrons is lesser compared to the mass of proton. Hence, when equal amount of forces were exerted on both the particles to deflect them, electrons were deflected more due to a lighter mass. All right, so this is an important exam question that has been tested. Why is this angle of deflection greater for electrons compared to protons? Moving on, the nucleon number is the sum of protons and neutrons, as we discussed in our previous lecture as well. In an atom, the protons always equal the electrons because atom is electrically neutral, and we've discussed that as well. Ion, on the other hand, is actually a species which has a charge on it. It can either be positive or can be negative. If it's positively charged, it's called a cation. If it's a negatively charged ion, then it's called an anion. All right. A positively charged cation is formed due to the loss of electrons. Meaning, in this case, the number of electrons is actually less than the number of protons. That is the reason why it gets an overall positive charge. And in case of anions, the number of electrons are more than the number of protons, due to which they get an overall negative charge. That is because of a gain of electrons. All right, whenever an atom gains an electron, it forms negatively charged ions or the anions. Whenever it loses electrons, it forms positively charged ions or cations. Now, so we've discussed this. Positive or cations are formed as a result of loss of electrons. Negative ions are formed as a result of gain of electrons. Moving on. Another term that you need to know is an isotope. Isotope is actually an atom of the same element having equal number of protons but different number of neutrons. Meaning the proton number for both of them is going to be the same, but it's actually the mass number that's going to be different. So they will have a different mass. Okay. So yep, this completes the discussion. Let's move on to the exam style questions. This is question number 2. In which species are the number of electrons and neutrons equal? So we need to count the number of electrons, but be careful here because we have some charges as well. Charged particles, meaning some ions as well. If I look at option D directly, this number that is written at the base is the proton number, and the number that is written on top is the mass number. And then this is the charge. The superscript is the charge here. Now, so protons are 8. Neutrons, if you subtract 8 from 18, you get 10 neutrons in here because you need nucleon number is just the sum of the two. And what about the electrons? If you have 8 protons and you have an overall charge of -2, then that means there are 2 extra electrons. So 8 electrons were previously present in here. After gaining 2 more electrons, you get 10 electrons in total. So 10 neutrons and 10 electrons in this case. So since electrons and neutrons are equal, option D is the correct answer. Question 7. This is just the numbering is not in order, okay? The diagram shows the positive paths of subatomic particles moving in an electric field in a vacuum. Now you can see this electric field right over here. Again, this a similar situation to the one that we discussed up in the diagram. You have a positive plate up and a negative plate down. Positive up, negative down, positive up, negative down. You have electrons here, neutrons here, protons here. Electrons, after entering the field, would be deflected towards the positive plate. This one is correct. Neutrons would pass straight and would not be deflected. Protons would be deflected down. So this one is incorrect. They're asking us which one is correct. So it's 1 and 2 only, because only those two show correct options. What about this one? In this scenario, they're just asking the composition of phosphide ion. Phosphide is 15p32 with a 3 negative charge up on it. So 15 actually means there are 15 protons. Neutrons are just a difference between them, and it's the same, so you don't have to worry about them. What about the electrons? There are 15 protons, so which means that it actually had 15 electrons. But because there is a charge of 3 negative, this means that 3 extra electrons have been gained, making a total of 18 electrons. So it has 18 electrons. Option A is correct. And the last question of this lecture, in which species are the number of protons and neutrons and electrons are all different? We need to check all of them one by one. Let's look at option C. Now, protons are 11, neutrons are 12. 23 minus 11 is 12. What about electrons? They're just 10 electrons because this is positively charged and the charge is +1 only, right? +1. +1 would actually means that originally it had 11 electrons, but after losing one electron, it is left with only 10 electrons. And that is how it got a charge of +1. All right, so 10 electrons. So protons, neutrons, and electrons are all different from one another, hence C is the correct answer. All right. This finishes off this discussion. Thank you very much for sticking by. Meet you guys in the next lesson. And the next lesson will also be related to atomic structure. Thank you so much.